Hello, everyone, and welcome to this evening's Pint of Science talk. We're hoping to be 1 hour. This will be Beyond the Bitcoin, how blockchains are changing the face of data. So thank you all for joining us. It's very exciting. We have a place for you to comment, so please do share. Let us know where you're watching from. And if you have any questions, please post them in there and I'll be checking throughout and we will be asking them at the end. My name's India and I'm very pleased to say that today we have two speakers with us. We have Dr. Joe Preece from University of Birmingham and we have Dr. Edina Harbinja from Aston University. So thank you both very much for joining. So we'll first be hearing from Joe, and then we'll go straight into Edina, and then we can ask them both questions at the end. So yeah, just put them in the chat and we'll get to them at the very end. So don't forget to tweet us and say hi and using the hashtag #Pint21. But otherwise, I think we should get straight into it. We've got a lot to cover. So thank you very much for coming. So first up, we have Dr. Joe Preece with Sharing is Caring, How Blockchains Will Help Eradicate the Paper Railway Ticket.
Thank you, India. Yes, so hello everyone, my name's Joe. Technically, I'm not actually a doctor yet. I've just passed my PhD Viva. However, I'm going to use the title because it's fun and fancy and I like doing it. We certainly do have a lot to get through. I've been given 20 minutes for this presentation for what is quite a complex topic. So I'm going to have to move at some pace, but hopefully we'll get to understand what a blockchain is and certainly how they can help eradicate the paper railway ticket. So just a quick outline of what I'm going to be talking through. I'll just introduce the topic a little bit. I'm going to do what's called a supersonic summary. So I'm literally going to try and blitz through what a blockchain is in about 7 to 8 minutes. Fingers crossed we do it. Once we understand what a blockchain is, then I will start talking about how we can actually use it in the rail industry for smart ticketing. And then I'll just summarize everything that I have discussed. So it's a topic which everyone probably is quite familiar at the moment, and it's the fact that Bitcoin continues to make the headlines. And there's one of my favorite stories here. So back in 2010, about a year after Bitcoin had been theorized and had started, and a chap bought a pizza for about 10,000 Bitcoin, which is worth, what, about 10 quid. Working backwards, we see that in 2010, a Bitcoin was worth about 1/100th of a pence, a tenth of a pence, sorry. Scroll forward to 2021, where we are now, and Bitcoin, £10, is worth about 0.0033 Bitcoin. And if you do the reverse mathematics on this, you see now that a Bitcoin is worth about £30,500, which means this lad who paid for his pizza way back when paid today's equivalent of £305 million. So it just shows the extremity of how Bitcoin has gone from pretty much nothing to becoming, a very lucrative asset to hold. So Bitcoin is a blockchain. Some of you may have heard of the term blockchain before. It's an important distinction to make that not all blockchains are cryptocurrencies. So you will have heard of Bitcoin, Ethereum, all that jazz. They're all blockchains, but blockchains are actually a bigger topic beyond that. And what else can they do? Well, that's what I'm here to answer. But before we do that, we need to know what a blockchain is. So 3 points to take home of what a blockchain is. Firstly, it's a distributed ledger. That means it's basically a record of all the transactions happening on the network. And the distributed part means that the ledger is shared and agreed amongst all users. So there's no central point. Everyone shares the data. Secondly, a blockchain is a data structure. So each transaction that happens on the network stores something of data. And the transactions aren't just limited to currency. So Bitcoin's a great example of it being a currency. It doesn't just have to be a currency. Thirdly, Bitcoin and blockchains are tamper-proof because it's built on lots of clever cryptographic protocols and a lot of fundamental mathematics which have existed for years and years. And you can't change a blockchain without considerable amount of effort. It's not impossible, but you'd have to have basically 51% of the computing power of a network to do, which in terms of, say, Bitcoin is infeasible. It's practically impossible. So the process is very basic. You've got two people. Alice wants to share some Bitcoin with Bob, and she uses an account, a private key, to sign a transaction. That transaction gets lumped into a block. That block gets transmitted to everyone on the network. They then mine that block to validate that all the transactions are okay. Once it's been mined, you can add the block, which is full of a ton of these transactions, to the blockchain. Hence, you get the term blockchain. And once it's been added, Bob receives his Bitcoin. That's a really simplified example, and we're actually going to go a little deeper for this talk. So I want to discuss the 3 layers of a blockchain, starting with the basic components. So this is the accounts, the transactions, all the bits that go on right down at the lower level. And everyone transacting on a blockchain has a public-private key pair. So a public key is basically a key you can give to anyone. It basically says, this is me, I'm, this person. A private key is mathematically related, but you keep it secret. It's yours. Only you can know about that. And you use that private key to basically digitally sign transactions, very much like a physical signature would be, where your signature is unique to you and you use it to verify that a document is yours. And together they make up an account. Everyone has one. It's important to remember. Here is our blockchain at the bottom here. So we're currently on block N. It's just a way of denoting that we're on the current block. This is the previous block and the previous block to that. And then these are the future blocks which haven't happened yet, will happen. And a block is usually made up of 2 components, header and all the transactions. So all the transactions are in this fancy tree-like data structure. Now, you don't need to understand the raw mathematics of why this happens. Basically, all the pure transactions are down here at the bottom, and every time you go up a level, you do what's called hashing the transaction. So it's basically taking the transactions, taking the raw data, and putting it through a mincer, if you like, and providing a unique output. And it's nice because you get an information snapshot of all the transactions in one short byte. That is also used by hashing the previous block. So all of the information contained in the previous block, that's all the transactions and all the header information, is hashed. And what it does, it gives you a snapshot of that block. So blockchain's tamper-proof because if anyone changes a transaction, say in this block here, so they would change the data in transaction A, it would change all these hash values, it would change all the mathematics, and it would basically break the chain. And this block here, when you're adding it, you'd be able to see something is occurring here. The previous blocks don't align with what I would expect. And basically you can reject the transaction, which is great. And that is basically why Bitcoin and blockchains are so well designed, is because they provide that security baked in. Now, the second layer I want to talk about is the network and the consensus. So this is actually how a blockchain network looks, not just the sort of micro components. So here's a really famous image. This is actually a really old image. It's from 1962 by a chap called Paul Baran, and it denotes 3 networks. So the centralized network is kind of like YouTube, like we're using now. So I'm this node here, and you as users are this node here. And our information flow is through these solid lines. Now, if YouTube's server goes down, that's it. It's game over, because there's no way that my information can be passed over to you at that point. It all has to go through a centralized server. And it's sort of the same with decentralized. Yes, there are other nodes of access that I could still reach if the server went down, but I'm still blocked off. Still wouldn't be able to get to you. However, distributed networks or peer-to-peer networks alleviate this problem. So say our node at the center goes down now, well, it doesn't matter because I've got a bunch of different ways that I can sort of try and find you and send my information across. And this is great, and this is what blockchain uses. So it uses these peer-to-peer networks so that all users share the responsibilities of storing the ledger at each node and maintaining the ledger at each node. There's no centralization. You're not having to send your information off for someone else to verify it, like a middleman. Now, this does mean nobody's in charge. So who decides what happens? Well, this is where we get consensus and mining, and a lot of you will have heard of Bitcoin mining. So a consensus, imagine you're running a node. So you're running one of those points that we just saw on the network. The way you do it basically is a 5-step process. Firstly, you update to whatever the latest state of the blockchain is. So you ask another node, give it to me, and they give it to you, and you update to the latest version. Then you listen out for new transactions on the network. So when people want to commit a transaction, they broadcast it, and they basically send it out to everyone. They go, I want to send 5 Bitcoin, to India. Can you do that for me? Thank you very much. You grab a few of these transactions and you pop them into a block. Now, this block hasn't been added yet. It's just a candidate block. You have to prove that all the transactions in that block are legit, mathematically sound. And the way you do that is via a relevant consensus mechanism. And a consensus mechanism is basically mining. So it's a way of verifying that a block has correct information and purely valid transactions. And then you send that block out. And once people agree that that block's fine, it gets added to the blockchain and the process continues. And everyone can do this. Anyone can do this. You could pull up a Bitcoin node now and try and add new blocks to the blockchain. You probably wouldn't be able to because the computing power required to add a block to Bitcoin right now is incredibly large. And yeah, it's basically this idea of mining. So there are a few varieties of approaches. Bitcoin uses this one, proof of work, incredibly energy inefficient. Some of you may have heard the fact that Bitcoin now uses more energy per annum than Iceland. And so a lot of academics are working on these problems as to how we can move over to a different consensus mechanism that doesn't use much energy as a small country. Finally, we have governance. This is important. It's kind of the bit that everyone forgets about. Who controls the software? Who writes the software? Who has that say on things? So the software determines how the platform operates. You've got to download the software from somewhere. It's always best to find distributed practices. So open source software is always the best because, again, it allows for anyone basically to go in and modify the code and make a pull request to GitHub, and basically keep the code modern and running as a group instead of popping it out to a centralized sort of consortium. Finally, I just want to go over 2 more goodies. Smart contracts. So these are basically transactions that you send onto a blockchain, and you send other transactions to that address to execute code within the blockchain. So you're actually having the blockchain act as a distributed computer, which is very nice because, again, because it's distributed, there's no reliance upon a middleman. And I'm sure Edina will speak a lot more about smart contracts and their legal implications in her talk. Another thing, there are tokens. So these are pretty simple to understand. Bitcoin is obviously a representation of currency. It doesn't just have to be currency. These tokens may represent real world assets. And we'll get onto that in a minute when I do tickets. So key takeaways, and I'll try not to spend too longer on this. We're already 10 minutes down. Distributed ledgers. So all of transactions between user accounts are stored on the ledger. It's a data structure, so it's essentially a fancy database, but all the users maintain it instead of a central point. It has a really good security, so you can't do anything naughty. And there are some extra goodies which make blockchain really applicable in a lot of use cases in the real world, like this one. So Tickets. Who recognizes what these are? Everyone, because everyone knows what a National Rail GB rail ticket looks like. And we know that because they are the best. They are the most abundant, but they are the best for a very good reason. Rail tickets in the GB currently look a bit like this. So you've got your paper ticket up here. But there are, a few different ways of buying tickets that you can do these days. So maybe you have a smart card, maybe you buy mobile tickets, maybe you get your tickets electronically. Yes, there is a difference between an e-ticket and an M-ticket, and maybe you're in London, or I think Manchester do it now with contactless cards. There are a few different ways you can sort of own a rail ticket, but with that come issues. First of it is ticket consistency. Say I'm in Land's End and I want to go to John O'Groats by the train. Hell of a long journey. I go through a hell of a lot of different train operating companies to do that. And each of these train operating companies will use their own platform to do those M tickets, those E tickets. The only single source that would work the whole way is a paper ticket. Also, we want to think about ticket integrity. How many times have you been traveling and your phone runs out of battery and your ticket is stored on the app and you can't prove that your ticket is valid anymore then? And you're actually, the law is in this country that you are subject to a £20 fine if you can't prove it, even if something like that happens. So we want to address these problems that we have. And just going back to it, how many ways are there to own a valid Great Britain railway ticket? The answer would probably astound you. So it's approximately currently 70 when you take into account all of the train operating companies who have their own apps and platforms. Okay, I'm gonna have to speed through now. We are running out of time. So this is the problem. We have 3 apps here. The different colors represent different train operating companies. And I buy 3 different tickets, 1 on each platform. The problem is I can't access it. So ticket 1 I've bought on the red train operating company's app, can't access it then on the yellow or the blue. And it's the same problem internally. If I buy an E-ticket, an M-ticket, and an S-ticket from one train operating company, it's usually the case where I can't then access that ticket on the other devices. It's locked in. And you end up with a problem basically that looks like this. So, we've got a variety of ways to store tickets here. Those who vend the tickets, the colours represent sort of who they can vend to, and those who validate the tickets. So I can buy from anyone. Vendor 3 obviously can send it to anyone, but vendor 1 can only send it to the red devices. Same with the validators. And you get these points of impossible data transactions. A validator 2 can't validate any tickets on red devices. And that's an issue because there are a lot of these holes that exist. And it goes back to that idea of ticket consistency and ticket integrity. So we need to share our digital ticket data. How do we do it? It's the reason I'm here talking about blockchains. Blockchains. The system for ticketing ubiquity with blockchains is a hell of an acronym, but I wanted to make it something railway related. It stands for STUB. And basically you transfer the tickets as those tokens that we were talking about, as transactions on the digital ledger of the blockchain. And we use smart contracts to make this work because it's all baked into the system. Now, as a data structure, the stakeholders, they can basically check this database really quickly. So you buy from someone else, but it's there on the blockchain, it's there on the ledger, and they can query that and validate it super quickly. So instead of our previous issue, we now have something that looks like this because I can access the ticket on any train operating company's platform. Likewise, I can now access the ticket on any device because it's account based. This is the important distinction, and we end up with a model that looks more like this because the E-tickets, M-tickets, and S-tickets can store anything now because all the ticketing data is stored on that distributed ledger. Every stakeholder can read that underlying data, and that's what makes this so clever. There are benefits because they are stored by an account instead of a device. Your ticket now just isn't locked into your phone because you chose to purchase there originally. It's everywhere. So if your phone does run out of battery, doesn't matter. You can access it on a smart card because it's not accessing from a device. We get better smart ticketing. Smart ticketing right now isn't smart. It doesn't do anything apart from store tickets digitally. By doing this, we could store tickets intelligently, prognostically, and use it to, settle our fares and store all our data in one convenient location. And, for the fans of privatization and the free market, it does retain competition because it still allows for people to compete on top of the platform. The platform is just the underlying asset. So I'm going to finish off now because I think that was about 20 minutes. So I was trying to keep it under. So the key takeaways: blockchains are great. They are distributed ledgers. They are basically a really, really fancy way of, transacting data. And they have amazing baked-in security, which makes them so smart. As for smart ticketing, it's currently not very good. It's not very smart. Let's move to something smart by using a blockchain, using our blockchain addresses as accounts, transacting and storing the tickets as tokens on that blockchain, and allowing the currently competing train operating companies and ticket vending organizations to share the responsibilities for maintaining it and using the same underlying data. Last thing, I knew I wasn't going to talk about finance tonight, but a bit of investment advice if you are looking to buy cryptocurrencies. If your nan starts talking to you about Bitcoin, it's probably time to sell because it means that everyone's buying it and it's probably about to crash. Unless, of course, your nan has a PhD in computer science, which is very, possible. So thank you very much for listening. Please, any questions in the comments, I'll try and answer them as I go along and a bit later on. Thank you very much.
Lovely. Thank you so much, Joe. That was amazing. And yeah, I think we're running to time, so that's really great. And yeah, if you have any questions, I can see a few coming through in the chat already. That's amazing. I will keep a track of them and we'll come back to them right at the end. Also, don't forget, you can tweet us at pint21, hashtag pint21. So that'd be really great. And yes, guess we should get straight up next to the next talk. So thank you very much, Joe. And now we will move on to Dr. Edina Harbinja from Aston University, whose talk is on laying down the law, the legal implications of blockchain, crypto assets, and smart contracts. So thank you very much, Edina.
Okay, great. Thanks, India. You can see my slides, can you?
Yeah.
Okay, that's lovely. Great. So thanks, Joe, for the lovely introduction to my talk, for explaining the technology and talking about the fun stuff. So sadly, I will now bore you a little bit, well, trying not to be too boring or put you to sleep, but to talk about the law around what has Joe just explained in terms of technology of a blockchain, cryptocurrencies or crypto assets, as I will define them shortly, and smart contracts that Joe already mentioned and gave you a use case of railway tickets. So let's start introducing the law in this area that is, of course, uncertain. So I'm going to talk a little bit about whether crypto assets that include Bitcoin and cryptocurrencies and other tokens that also Joe mentioned and some other things can be considered property in law. Are they really property at the moment, especially in English law that I will refer to in this talk? And then I will return to smart contracts and consider whether those smart contracts are very smart in terms of the law and whether they're really contracts in law at all, and what is the future in this area. So I hope that this will be understandable and will give you some answers, or at least initiate some questions. So crypto assets that I will define here as a digital asset created or implemented using cryptographic techniques. So the techniques that Joe has already helpfully explained. So the asset that is created by with these methods are basically existing only in a digital form, and they are called cryptoassets, and they're wider than just Bitcoin and currencies. So their features, the key features of these are intangibility, so you can't touch them, they don't exist in a real physical form that we know traditionally for other types of assets. Cryptographic authentication that Joe has talked about, hashing, private public keys, then use of distributed transaction ledger, blockchain, and then decentralization again that Joe has talked about really nicely, and ruled by consensus, and consensus mentioned by Joe as well, consensus proof of stake or proof of work that he explored. So just briefly, you have heard all of these features already from Joe. I was just restating them in terms of that they apply to all crypto assets essentially. So the first question that we lawyers like to ask when we talk about new forms of assets, something new emerges in technology, lawyers and regulators, lawmakers, policymakers like to ask the question, well, is this property? And it's because the property is one of the supreme rights in the current economic and social system in capitalist countries. So if we can propertize a thing, an intangible or tangible thing, then we can do a lot of things with it. So we can sell it, we can enjoy it, we can pass it on death, etc. So what is property? Well, property is not in law. When we say property, we don't really refer to the physical thing, such as your house. We refer as a relationship between you and that house. So the relationship includes the right to use, the right to sell, the right to destroy, the right to pass on when you're dead, amongst other incidents of property, as we call it in law. So I hope that's quite understandable, but I just thought it would be interesting and important to make this distinction at the beginning. So we define crypto assets with features that I have referred to previously. So do they qualify as property? Can we own them? So we as humans, especially in these sort of, as I said, socioeconomic relationships, we like to own things. We like to say this is, we possess this, we own this, we can do with this whatever we want, we can sell it. So same with crypto assets. There are some problems in the current conceptions of property and ownership, and whether we can actually possess these things because they're intangible, because of the nature of decentralization and where they are and how they operate. The possession, as we know it in the law, does not fall squarely within those features. And especially in the law of England and Wales, does not currently provide certainty, and I'll just explain shortly why. So the law is quite traditional as a discipline, as you can imagine, quite conventional. And in England, there is this long-standing principle from the 19th century case, Colonial Bank and Winley, that all personal things are either things of possession or things in action. The law knows no tertium quid, meaning no third thing between the two. So any property is either thing in possession or a thing of action. If it's not either of those, then it's not property. Okay, this might sound a bit confusing, but I think I'll explain it a little bit better on the example. So helpfully, we've had a case quite recently, a year ago, a bit more than a year ago in the English High Court, that this case of AA and persons unknown, where the court considered whether Bitcoin could be considered property so that it can be recovered with what is called an injunction from those who have taken those Bitcoins, or actually those who were paid Bitcoins because they performed an attack. The hackers performed an attack on a company's systems, and they asked for a ransom in Bitcoins, and that was paid by the company. But an insurer of that company managed to find out where those Bitcoins were and trace them back to the Bitfinex exchange. So the question to the court was whether this is a property that they could recover, the Bitcoins themselves. So the court said, in this case, made an analysis of the technology and said that bitcoins are not choses in possession or things in possession, as the English law calls it, because they're virtual, so we can't really possess them as we possess other things. They're not tangible, we can't touch them, and they cannot be possessed. So they can't be one of the two types of property, essentially. Secondly, they're not choses in action or things in action because they don't embody right capable of being enforced by action, meaning we can't sue to enforce this property. An example of this weird category of property is copyright or patents, for example. That sounds probably more familiar to you. And these are types of property or choses in action because you can sue someone and recover that property or recover something in exchange of the property. So the court in this case, and Justice Bryan basically concluded that a cryptoasset cannot be or might not be a thing in action that we defined because of the possession problem and intangibility, or it cannot, and it cannot be thing in possession either. So it could be something else. What he basically concluded was that it doesn't mean that it cannot be treated as property, contrary to the principle that I've mentioned before, that there are only two types of property. The judge in this case thought that crypto assets such as bitcoins are property. So we have some form of clarity stemming from this case, but there are still questions because the law is unsettled and precedents have not been established properly in this case, from this case. So the reasons where the judge thought that this was property, that crypto asset could be property, and Bitcoin in this case, is because it's definable. We can define it. It can be identifiable by third parties. So Bitcoins are easily identifiable, as you probably are aware already. And a third party can assume their nature. We can assume what they are, and they have some degree of permanence. So they don't have to be absolutely permanent, which could be a problem with many digital assets, including crypto assets. But some degree of permanence is required, and the judge in this case thought that this was the case with Bitcoin. Another question that we would ask that is logically following from this analysis is, who is the owner then of this Bitcoin or this crypto asset? So what Andreas Antonopoulos said in 2016 in this famous quote is basically, not your keys, not your coins. So if you have a private key, if you have a key to the coins, a key to the asset, crypto asset, then you are the owner. So that would possibly, arguably, provide some help in determining who owns those crypto assets. If we agree with the judge in the previous case, of course, that Bitcoin and crypto assets could be property in English law, and then, of course, in other areas of law that are similar or a little bit different as well on the continent, but with similar overarching features of property. So to conclude this analysis on property, the uncertainty still remains. So this case law hasn't settled the issue and hasn't considered a wide, many more types of crypto assets that we can with certainty conclude that these are property. So the Law Commission of England and Wales, which initiates and discusses law reforms and proposes them to the government, initiated this consultation on whether crypto assets and digital assets can be considered property, and it's an ongoing consultation, basically a law reform that has been announced, and we can expect it to be concluded in the next few years. So the Law Commission aims to ensure that property rights in these assets, in digital assets more broadly, but also crypto assets, receive full and consistent recognition and protection under the law. So we can expect, in other words, that crypto assets could be quite shortly recognized as property in English law, which is surprising for some commentators, given that the law has traditionally been very reluctant to recognize new types of property. Okay, so moving on to smart contracts, and Joe has mentioned his example of a smart contract using the railway and the contracts that we conclude with railway companies, for example. So what is a smart contract? Well, smart contract in legal terms, and now I'm referring to the Law Commission's definition. The Law Commission has initiated another consultation on smart contracts separate from property in digital assets, and considering whether smart contracts are contracts in law. So basically, for contracts to be recognized in law, for those smart contracts that are based on blockchain, they need to be considered as legally enforceable. So they can be enforced in some form by the law, by courts, etc. These contracts are, of course, automatic. They are programmed, and individuals cannot tamper, as Joe explained, with them. So the process is automated. It's a computer program, basically, and that is deployed on a distributed ledger technology. So those are the three key features of smart contracts. And there are three main types of smart contracts identified by the Law Commission and also scholars. And the first one is easy, because it's not very, very new. It basically, it is a normal contract that we know. It's the natural language contract, the regular contract with automated performance. So the whole negotiation and the terms are concluded in natural language and our human language, and it's only performed by the code and in blockchain, for example. So the law would not struggle much with this type of contract, because most legal principles would apply, same legal principles as for traditional contracts. The second type of contract is a hybrid smart contract. So here, negotiations between parties will happen offline or in a natural language. And then the terms will be programmed and coded and deployed in blockchain, and the performance will again be automated and executed in the distributed ledger. So that's a bit more advanced, but still, the most interesting type of these contracts is the solely code contract. So negotiations will happen, because the negotiations are in most cases not a formal part of the contract. They would happen either in natural language and could also happen in code. But importantly, terms will be programmed, and performance of this contract will be triggered as programmed by the code and deployed in a distributed ledger. So these are the most interesting contracts for the law reform, because they are new, and the law potentially struggles to include or recognize these by using traditional forms and traditional legal principles in contract law. So an example of this wholly automated contract we can find in something more less advanced or less smart, like a vending machine, where it's programmed that if you put in a money and select a snack is dispensed. So if we, just to make it a bit more digestible, the example is used, and then if we program this in, say, Ethereum as an example of smart contract, the smart contract would look like this. I'm not, of course, a techie, and Joe will know how to read this much better, but this is just an example for you, just to take a look and see what this looks like in code, this program that is coded. This contract. However, so when I mention Ethereum and the smart contracts that are types of accounts in Ethereum, they're not really contracts in any legal sense, because they are basically computer programs which run automatically, and they're not legally binding contracts that will produce enforceable results. And I think one of you asked, Joe, in comments, why don't railway companies adopt this? Well, because these smart contracts are still not producing legal effect, because they're not recognized in law. So the founder of Ethereum said, interestingly, that he regrets adopting the term smart contracts, because these are not really legally enforceable contracts, and he should have called them something more boring, like persistent scripts. So I found this quite interesting, and it's quite true, because these are not legal contracts. So the benefits of these contracts, some of them also Joe explained a bit before. Increased efficiency, of course, lower transaction costs because there's no middleman, lower enforcement costs as well, because again, we are getting rid of some of the traditional institutions in the law enforcement. Greater trust because of the features of blockchain and immutability, etc. Then certainty that this will be executed in code and we don't rely on human error and trust in humans, and reduced risk of fraud. And Joe gave you an example on how difficult it is to tamper with this and how much power you need to do that. So use cases include for smart contracts include insurance policies, for example, and insurance contracts that can be programmed in blockchain, but also the great example that Joe has given you already in railways. So what are the problems with these smart contracts? Not smart contracts in the Ethereum, but smart contracts in law. So in law, these wholly automated contracts, there are problems in how we interpret them using the legal interpretation methods as we know already traditionally. And then, for example, how does a notion of mistake of a contract applies to smart contracts? If we realize we made a mistake, how can we correct that, and how that can be executed in blockchain? And then, of course, remedies that are available when smart contracts does not perform as intended. How do we remedy that? Does the law need new remedies introduced? And of course, still existing problems with technology, such as trust in this technology, that will increase or decrease adoption in the future. Security issues that exist. Barriers to entry due to technological literacy or even software and power and sustainability in terms of the energy consumption. These are all some of the issues that are, of course, non-legal, but also relevant to what law will recognize eventually or not. So I will conclude with just saying that the English law has an ambition to recognize these assets in these contracts. It is on track to do that because it wants to be one of the first jurisdictions, and it wants to be a jurisdiction of choice for people to come and decide their disputes here or choose English law as applicable law. So the UK jurisdiction task force led by senior judges has concluded that English law is well able to deal with technological developments. We can criticize that, and I don't necessarily agree fully, but it does has a track record of doing so in recognizing, for example, quotas as property or emission in terms of air pollution, etc. So some of the intangible forms of property. So I'll conclude with that saying that some of you will probably not want the law to interfere here, but the law is definitely chasing the technology here, and the English law is determined to catch up and put these new things into the old or some revised law boxes in the area. Thank you.
Amazing. Thank you, Edina. That was really great. Thank you to both our speakers. And it's really nice. I can see lots of conversation and questions coming in through the chat. And we have, perfect, for about 15 minutes to go through some questions, if you're both okay with that. So let's start with, go all the way back, and we can put them up. So we have our very first question, which came through from Steve. Can we all see that? Brilliant. So do you think, this one's for Joe, this was just at the end of Joe's talk. So do you think a smart contracts network will dominate in the future like Google dominates the search results?
Yeah, it's a difficult question to answer. I mean, a lot of people compare sort of the current, bull run, market of blockchains as the .com bubble, back way when in the 90s, when you had so many new ideas coming out through the internet, and then only sort of 5 or 6 big ones emerged from that, victorious. Ethereum is currently the leading smart contracts platform in terms of market cap. So it's got the most volume of fiat currency in it. But I think there's still a few years yet to see which one is technologically sound, because Ethereum isn't the only one. There's also interesting arguments between, Chinese platforms and sort of more Western-based platforms. So Ethereum's considered a more Western platform, whereas its competitor Neo is very much a Chinese institution. Even though they're distributed and anyone can use them, the origin country, has a big say in that. So I think you'll see Ethereum continue to dominate in that regard. But I don't think it will be as concrete as sort of Google's dominance in the search engine market.
Yeah, thank you very much. And we have a question for Edina, which was, are other types of currency considered property? So does it, yes, it just replace it. That's good.
Yes, I presume the fiat currencies or the normal traditional currencies, yes. Yes, they are. In English law, definitely. So, but as I explained, because of the problems with possession and tangibility in particular, there was this question around, and it still is around cryptocurrencies that needs to be resolved into. Thank you.
Brilliant. So let's find another one got loads of questions, so got to pick through them. So a question for Joe. There was a comment here, lovely, saying, thank you for your talk. Is there any reason why companies do not implement these kinds of solutions? The benefits are clear to customers, but are there any disadvantages for businesses? And I know that Edina, you also sort of commented on this in your talk.
Yeah, I was literally just going to say Edina's probably answered most of it. The reason why none of this has been implemented yet on a wide scale is we're still working it out. This technology is very new. It's only 10, 11 years old at this point. And whilst on a technological basis, it all works, we can see that, my research is purely theory in that regard. Actually doing it when there are laws, a big one at the moment is GDPR. So we're talking about distributed databases where you cannot delete something. How do you delete an individual's data when they request it to be deleted, as is the law of GDPR? So yeah, it's not the technology that's holding us back. It is us, and it's a law, and the law needs to be there. But yeah, it's going to be interesting how that shapes the route to it. I'm sure you've got plenty to comment on this.
Yeah.
Or maybe not.
Edina, do you have anything that you'd like to add to the question?
No, definitely. As I said before, I think the English law is on track probably to recognize this fairly quickly for law, because for law it takes years to first suggest, for example, law reform by the Law Commission that I mentioned. Even if the Law Commission this year concludes that smart contracts should be contracts in law, it needs to suggest the law reform to the government and the parliament, and it might take a few years to recognize this, and who knows where the technology will be. But the Law Commission is looking for views, and I think those of you who have something to say and contribute in terms of technology and the use cases and how this works in practice, the Law Commission is really curious to find out and learn about how quickly and to what extent it should be recognized, and then I think that will help with the greater implementation and the usage of technology itself.
Brilliant, thank you both. And Edina, we have just had another question come through for you, saying, would recognition of crypto as property lead quickly to regulation by the FCA?
Yes, definitely. That's probably one of the important aims. And if when you categorize and regulate something and recognize it as property, there are different implications that, of course, some of them are regulatory, some of them are tax implications that a lot of the people who are into this would want to avoid, of course. And others are, of course, data protection and many other areas of law that will be then involved when we and if we recognize this properly. So when you have an unregulated, uncharted territory, as some of the techies would like this perhaps to remain, these questions are arising, but not pertinent. But I think in England especially, coming, and we can't avoid it. It's bad news probably for a lot of you, but the regulation is rapidly coming to get you or us.
Brilliant, thank you. So my next one for Joe, I believe it was. So does this mean that ticket data would be held publicly rather than individually by trained companies?
Yeah, so one of the things I didn't really dive into today, because we just didn't have the time to do it, was the difference between what's known as a permissioned blockchain and a public blockchain. So we spoke a lot about Bitcoin and Ethereum, they're public blockchains, because it's easier to talk about that. They're the ones everyone know. Once again, I refer back to my comment at the start. Not all blockchains are cryptocurrencies, and you can run them in a private sense. Now, a lot of people think that's redundant because the whole point of blockchain is this philosophy of, you're taking control away from these big central units. Not entirely. It's all about that distribution of data, and it's more than that we're sharing the data between the companies. So it's not public so much, but it is shared, and it certainly is in more of a public domain than it would be as it currently is, where yes, the individual train operating companies have their own servers, they have their own databases, and they take care of their own stuff, and they don't let anybody else see, because that's just the way companies work at the moment. They don't want to share their data without getting something in return. So it's nice to propose this solution as something which sits under the competition which sort of lies on top of it, as opposed to changing the entire model. Yeah, good question.
And so we have another question actually, which you might want to cover, Joe, or both of you, but are there any cryptocurrencies which are doing a good job of resolving real world problems at the moment, other than Bitcoin potentially replacing gold as a store of value, of course? I don't know who wants to take that first.
Yeah, I can go. It's hard to say. Again, it goes back to the point I made earlier of we're still finding our feet. And you can go on websites like CoinMarketCap, and there are thousands of these things that exist now, all trying to do their own particular thing. And 99% of them are garbage because they're not really solving anything. The ideas are there, but we have to wait and see if those ideas actually come to fruition with anything. So currently, right now, I've yet to experience something in my life personally where a blockchain has actually benefited me, such as a ticketing system would. The only thing it's good for at the moment is making a bit of cash on the side. And that sounds bad, but yeah, I think we're a few years away from really seeing those use cases which are the good ones, and which will actually solve some real world problems. I'd like to think there will be. There are some really good ideas out there, but we need to get rid of some of the chaff, like Dogecoin and stuff like that. Long way to go.
Brilliant, thank you. Which I guess leads us nicely onto James's question, which is, I heard that distributed cryptocurrencies could remove the need for centralized banks. Is this true? I don't know if either of you want to take this one. I don't know who it was aimed at.
Take it, Edina.
Yeah, I think yes. In principle, that would be the purpose or the aim of this to remove the middlemen and to remove the need for centralized banks. However, I don't think that I think that the banks have realized that obviously quite quickly, and then trying to use it for their own advantage and moving some of their operations and some of their systems to blockchains. The RBS have recently announced the use of this. So I think I'm not sure if we can, even though the idea was to get rid of the banks eventually by some of the libertarians and techies in the field. I'm not sure how really how possible this will be, and I think that those big companies will definitely find their ways to use it to their advantage. I'm not sure what Joe thinks.
Yeah. Again, it's a really interesting question, because it's a whole philosophy of why it started. Of let's get rid of the banks because the banks are evil. All bankers are evil, and well, that's partially true. Part of me does like having a centralized bank, because I know that my money, when I have it in my savings account, is regulated by the FCA. If they go under, I'm backed up for £85,000 if I need that. I don't know if any of you have ever transferred money over a Bitcoin network, or any blockchain network for that matter. It is terrifying, because if you get your address wrong, if you get your private key wrong, certainly with a public address, you send the coin elsewhere, and that's it. There's no one to turn to say, oh, can I have that back, please? So there's that element of trust that we have with banks, that, okay, you're, partially evil, but actually, I like having some of my money there, because I know it's somewhat safe. It's government regulated. Certainly in this country, I can't speak for everywhere in the world, but it doesn't matter who's in government in the UK. The banks, and our money is, very, very safe. So I don't think it's going to fully replace, but I think it will maybe kick these banks, up the bum a little bit to, reform, hopefully.
Great, thank you both. So I won't be closing all my bank accounts right now then.
Not yet.
No, hold on.
Lovely. Leads us on to a good question next, which is, how do we attribute value to cryptocurrency, and what happens once Bitcoin is fully mined? I don't know who wants to take that. Joe, do you want to take that?
I can take it, yeah. Value is trust between people. Think about gold and diamond. Think about what it's useful for, and then think about how people hold its value. So we like diamonds because they're nice and they're pretty and they're rare, and they take a lot of work to get. So they have this inherent value, and we can trust that if I buy a diamond off Edina, I can probably sell it at the same price to someone else. And it's that trust, of this asset will do something for me in return, as to why it sort of keeps climbing and keeps going up. As for when it's fully mined, we're a long way from that, so it's hard to say, because in a way it makes Bitcoin more rare, because there's nothing new coming out into the system. Mm-hmm. So you'd expect the price to sort of rise, but it's tough to say, and I'm put my hands up. I'm not an economist, so I'm probably not best to answer that. Edina, have you got any thoughts?
Yeah, no, I agree. I'm not an economist either, but yes, it's the question of rarity, it's the question of trust, it is the question of course, of offer and demand, and in this case, people recognizing the value between themselves, and this the hype, if you wish, that attributed value and some of the initial excitement. But yeah, it's a volatile thing still, and we're far from having it comparable to diamonds that as Joe said. So yeah.
Thank you. We have time for just one more very quick question, because I'm interested to hear your thoughts on it. So Bella asked, Elon Musk considered to be manipulating crypto market value, and will he be held accountable in law?
you can argue that he is, his market share of Bitcoin is not actually that high, but it just demonstrates the power that he has over individuals. A lot of people really like Elon Musk. I don't quite understand it myself, but whatever that he says, they hold it as gospel. So if he says something bad, it triggers a lot of people to sell. Hence, the market crashes. Now, whether he did this purposefully, to try and make an advantage on his own, then it's hard to say. And will he be held accountable in law? I think that's one for Edina to answer, to be honest.
Yeah, so potentially if that could be established as some sort of market manipulation, but this would be decided based on the US law, most likely, because that's where the manipulation would be either tried or established if initiated. So it's a question for the US law, but I think there are definitely, generally, as far as I know, that there could be legal principles in terms of market manipulation applied, and it would be perhaps difficult to prove that, but there are established legal principles that could be invoked, perhaps, to Elon Musk in this case. Or
brilliant. Thank you very much. Right. Well, we have. Oh, yep. We've reached our hour. So I'm really sorry if we didn't get to your question, but we've had quite a lot, and I tried to get through as many as we could. But thank you both so much for coming and giving amazing talks. We had Dr. Joe Preece and we had Dr. Edina Harbinja. So that was amazing. Thank you very much for coming. Thank you all for coming to watch and for your questions. It was so interesting. It's been great having everyone here. Also, huge thank you to the Pint of Science Central team for helping bring this all together. Do check out the talks that are going on throughout the Pint of Science 2021 event, and hashtag on Twitter, Pint21. And thank you all very much for coming. It's been wonderful. So thank you all. Thank you, Joe and Edina, as well. Again.
Thanks for hosting us.
Thanks, everyone.
Bye, everyone.
Have a good evening. Bye.
Bye.